Hi friends, this is Hari Babu, Department of EEE, Chibrol Engineering College. I am going to deal the subject Electrical Measurements, Unit 6, Digital Meters. The syllabus code in this unit already have have completed introduction, digital voltmeters, successful approximation type dBm, ramp dBm, and also dual slope indication type of dBm. So in this video I am going to discuss digital multimeter, frequency meter, and tachometer. These three topics I will cover in this video. The topic is digital multimeter. So the digital multimeter we already used in the many laboratories actually, and also in house its purpose also. So the digital multimeter is used to measure the AC voltages, DC voltages, and AC and DC currents, resistances over several ranges actually. Okay, so the current is converted into voltage. Actually, the current is converted into voltage by passing through a low resistance. Actually, it is already we know that that is the basic circuit diagram for a digital multimeter is the basic circuit diagram. Okay, here is a AC, this is the AC manner, and DC, and this is ohms. Nothing but a AC values can be measured in this path, and DC values can be measured in this path, and ohms nothing but resistance can be measured in this path. Okay, so here we use a current. The current is converted into voltage. The current is converted into voltage by passing a low resistance, that is low resistance by connected in shunt way, that is low shunt resistance actually. Okay, the AC values can be converted into DC by applying the various rectifiers. We know that the rectifier can be converted into AC to DC, right? And also by using the filter circuits. Okay, while for the resistance measurements, for the resistance measurements, the meter consisting of a persistence low current source that is applied across the unknown resistance while gives to the DC voltage, right? So while gives to the DC voltage, right? All the quantities are digitalized using analog to digital converter and displayed on the display, right? Displays on the display. So in this, the analog multimeters require no power. Okay, no power supply actually. They suffer less from the they suffer less from the noise also and isolation problems also. But still the display meters have some following advantage over the analog multimeters. Analog meters, the advantage of digital multimeters over analog meters are the accuracy is very high, and also the impedance is very high, and also there are available in very small in size actually. Due to the improvement in the integrated technology, the prices also somewhat low compared to analog. Okay, coming to the actually the basic current circuit, current to voltage converter. Actually I mentioned previous that is the current is converted to voltage by passing it through the low resistance. That is the circuit is, this is the circuit. Okay, in this the unknown current is applied to summing junction. This is the summing junction. So this is the summing junction at input of the op amp. This is the op amp, input of the op amp, right? As the input current of op amp is almost actually zero, so then the current IR and IA is almost same. Okay, are equal. IA is equal to IR only, because the input current is almost zero for op amp. Okay, this current IR causes a voltage drop which is proportional to the current to be measured. Okay, this voltage drop is the nothing but an analog input to the analog to digital converter. Okay, analog to digital converter. So thus providing a reading that is nothing but a proportional to the unknown voltage or current, sorry, unknown current. Okay, in order to measure the resistance, here also in order to measure the resistance, a constant current source is used. Already we have mentioned that a constant current source is used. So the known current is passed through the unknown resistance. The voltage drop across the resistance the voltage drop across the resistance is applied to the analog to digital converter, hence providing the display on the value of the unknown resistance. To measure the AC voltages, the rectifiers and filters are used. We already know that. Okay. In addition to that, visual display, the output from the digital multimeters can also use it to interface some other equipments also. Okay. So these are the some advantage. These are the some process to convert the current to the voltage, and also use it to AC to DC. Right. Some analog to digital and analog to digital multimeters, we have some advantage and disadvantages also. The comparison, but I have not mentioned here. Okay. Let us tell. Actually, in the analog electronic multimeters, no power supply equal. Here also digital multimeters some power supply required because battery supply required. Okay, it suffers some less noise in the case of analog, but in digital multimeter it suffers some electronic noise actually. Okay, isolation problems are very less in case of analog, but isolation problems are more in case of digital multimeters. Okay, so accuracy is very less in case of analog. In case of analog we have isolation, accuracy is less, but in case of digital meters we have high accuracy, right? So okay. Coming to the next topic, digital frequency meter. Digital frequency meter. Okay, the major equipment, the major components used in this digital frequency meter is input signal conditional circuit, time based generator, gating circuit, decimal counter, and also digital display unit. Okay, the basic circuit diagram. Okay, the block diagram of digital frequency meter is this one. Okay, I already told that there are four main ports are there. Input signal conditional circuit, I think, but this is the input signal conditional circuit. Okay, time based generator, nothing but this is the time based generator. This is the time based generator. Okay, right. Third one is gating circuit, I think, but this is a gating circuit. Okay, this is the gating circuit. Next one, decimal counter and display. This is the decimal counter and display unit. Okay, so the first one, input signal conditional unit, and this is the gating circuit, and this is a decimal counter and display unit, and last one is time based. This is the time based generator. This is time based generator. Okay, right. Okay, from this first one is the input signal conditional unit. This is the input signal conditional unit. Okay, in this circuit we have used amplifier and Smith triggers. Okay, the threshold voltage of Smith trigger can be controlled by the sensitivity controlled by the control panel actually. Okay, we have not mentioned here. First of all, the input signal applied to the amplifier. Okay, amplifier, so which amplifies the voltage which sent to the signal Smith trigger. The Smith trigger can be converted the square, that is a square wave, so that is a square wave converted to square wave. Actually the amplified signal can be converted to square wave by using a Smith trigger. Okay, next, time based generator. This is the time based generator. In this we have 1 megahertz and 200 megahertz depending upon the requirement. Okay, the accuracy of a digital frequency meter depends on the accuracy of the time based signals produced here in this. Okay, the output of the oscillator, here I mentioned a crystal oscillator, that is 1 megahertz oscillator, so which produces a sine wave which connect to the Smith trigger. The sine wave can be converted to square wave by using the Smith trigger. Okay, the output of the oscillator, that is the output of the oscillator is square wave which is converted to square sorry, this is sine wave which is converted to square wave by using the Smith trigger. Okay, which is connected to the frequency dividers. These are all the frequency divider. Thus a train of pulses are obtained after each frequency division. Using the time based selector, so which yes, that is the gate time can be adjusted actually. Okay, this is about time based generator. Right, next one is gating circuit. This is the gating circuit. Okay, The gating circuit consists of a AND gate. This is a AND gate actually. When the enable signal is provided, to the gate, it allows the train of pulses to passes through the gate. Okay, passes through the gate for the time period selected by the gate time circuit. The pulses are counted by the counter. This is the counter. The pulses can be counted by the counter, right? So when the gate is disabled, then it will be closed it. Okay, so the number of clock pulses can be counted by the, this is counter. Okay, uh, right. So this is about actually four different main components in this frequency meter. Okay, coming to the next important, that is a basic block diagram. Actually, this is the basic block diagram of frequency meter actually. So I will complete a small way. So the signal waveform, this is unknown signal which is connected to the amplifier. The amplified signal will be connected to Smith trigger. So this sinusoidal wave can be converted to square wave by using the Smith trigger. Okay, now likely I have mentioned previous also, the output pulses of Smith trigger. Sorry, the output pulses of Smith trigger is fed to the start and stop gate. Actually, when the gate is enabled, the input pulses passes through the gate and the fed to the directed to the counter. Okay, which counts the number of pulses. When this gate is disabled, then the counter stop counting of the input pulses, and which displays on the display, that is digital display. This is the normal basic block diagram. Okay, I have mentioned previous is number of parts, this is number of components used in digital frequency meter. So by using this one we can measure the frequency by using the digital counter. Okay, the next topic is digital tachometer. The basic diagram of digital tachometer is this one. We have here a gate generator, samely previous case also, here also the same processor. So this is a gate generator and revolutions, that is RPM, nothing but revolutions per minute. So this is the main gate circuit, and the counter, this is the counter counted by the number of pulses. The counter can be counted by number of pulses which you gate enabled and disabled duration of time. Okay, now which displays on the display. Okay, digital tachometer, the why it is used, digital tachometer is used to measure the speed. Okay, now it is used to measure the speed of the motor. Okay, the technique used for the measurement of a speed of a rotating shaft of a running motor is same as that of the conventional frequency meter. Same it is, actually both are same. Consider, that is, let us consider the revolution per minute of the shaft is R. Okay, assume that the number of pulses produced in the one revolution is P. Okay, thus in 1 minute the number of pulses from revolution pickup can be calculated R into P. Okay, so then the frequency of the signal is given by R into P by divided by 60 per minute. Okay, so suppose the gate speed is G, then the pulses can be counted R into P into G divided by 60. Okay, now the direct reading can be possible in RPM if only possible the gate period is 60 by P only. If it is multiplied with this, then we can get as a, that is R, nothing but a revolutions per minute, that is one revolution. Okay, that is revolutions per minute can be obtained by in this way actually. Okay, that is R. Okay, thank you. This is about digital meters. So we'll continue in the next topic. Thank you.